Well, good morning, and thank you for coming. I know it's bright and early on the last day of the conference. Anyone here is better than anything, better than nothing. All right, so I'm Jason Cline. I'm the engineering manager, or I'm a engineering manager at Sencha. Is everybody here kind of familiar with what Sencha does in general? We're a JavaScript frameworks company. We make toolkits for both desktop and mobile, and we're fairly popular on the enterprise side for building in-house apps, line of business apps, and we've got a lot of customers in that that use our stuff. But what I'm going to talk to you about today is a new product we've launched called Space. And Sencha Space came about because of a problem we were encountering with a lot of our customers. The browsers we have today, even though they've come a long way in terms of their capabilities, functionality, HTML5 is awesome, data storage, great, WebSockets, awesome, all the great new shiny toys we've got with modern browsers are amazing. They're great. But they still leave a lot to be desired. So consumer browsers, all the ones you see up here, the ones on your mobile phone, they're all oriented towards consumers. So they're more concerned about anonymity and privacy for the user. They tend to be reliant on ad monetization models. There's a lot of, basically they don't have any features that are interesting to enterprises. Enterprises don't want you to be able to browse anywhere that you want to go. They want to make sure that you're authenticated. They want to know who you are. They don't want you to be anonymous. And that created a problem for us. So a lot of our customers are coming to say, hey, these browsers, particularly on mobile, just aren't secure enough for us. We can't put our business critical, multi-billion-dollar business on a mobile browser. We can't put the critical apps there. So our solution to that for a while was packaging. But and there's lots of great tools for that. We support PhoneGap and Cordova, so you can take your HTML5 app and you package it up, put it up in the App Store. But it's a bit of a compromise. We have to, as a developer, you build your app, and normally, we used to just put it up on a web server and it was ready to go. But now we've got to package it. We've got to do that for every single app store, and we could use a build process and maybe do that in the cloud, make it a little bit easier. But if you're trying to do that across an enterprise where you might have dozens or hundreds of applications, managing that starts to become a problem. You have different release cycles, different delay cycles for when you submit an app to when it actually gets up in the App Store, different rules for every app store that you have to maintain or not maintain. There's enterprise deployment models. It's really complicated when you try to scale that up across an organization. So, and the other big thing is that packaging by itself doesn't give you that much more security than running things inside of a browser. Now, it makes sure that the user, when they launch the app, only goes to one place, and all the files for that site come with the download, and you get that amount of security. But when it comes to true security, the ability to protect the data that gets downloaded onto a phone, packaging by itself doesn't add anything. Your data is still stored in the clear. If it's relatively trivial for a moderately skilled hacker to open up your phone and grab the apps off of it and unzip them. Basically, all you really have to do is unzip them, and all your data is sitting there. And that's really not good enough for our customers. And so what we found they were doing, each one by one on their own, for the ones that were big enough, they were going out and hiring security firms, and they were building extensions onto their packagers, or they were building their own packagers that basically would add all the security features they'd need. And some were successful at that, some weren't successful at it, and the majority just didn't have the resources to do it at all. So we thought that maybe we could help that problem. Now, the other thing that was kind of happening all at the same time is this, you've probably all heard of it, BYOD, or bring your own device. Because end users, businesses aren't buying everyone phones anymore, or at least they don't want to. And users really don't want to carry two phones around because they've got their own personal smartphone that's probably better than the corporate one that they're provided with. And it's really not a great solution. So what BYOD, where it's basically bring your own device, started happening. And so users were demanding, I want to be able to run my app, the corporate apps on my device. And of course that made the IT departments across the globe panic. Because we can't just put our apps on some uncontrolled device. So there's an entire industry that's developed over the last 4 or 5 years around basically creating a Frankenphone, if you will. They'll take your phone when you started a company, and I don't know if anybody you have gone through any of the trials with any of the providers out there, but what they'll do is they'll take your phone and install a rootkit on it. They'll root your phone, put some proprietary software on it, and that controls what networks you can connect to, how you can connect to them, what apps you can install, what apps you can't install, and what you can and can't do. So you've kind of got this phone that's yours but not really yours anymore. And that's kind of annoying for your employees because now they've got this phone that is they have to take into the IT department to get access to get their work done. And then if they leave the company, they have to take it back in to get it, kind of detangled, and hopefully that process works really well. And for IT, it's a burden too, because now every employee has to come in, bring their phone. Maybe they've got an iPhone, or maybe they've got Android or Windows Phone, or there's new platforms coming out all the time. So which ones do you support? And the overhead and the burden of actually doing that process is non-trivial, especially as your organization scales out, because you've only got a relatively small IT department, and they're already busy, installing virus software on their PCs and whatnot. So, and the other problem that I haven't really mentioned yet is for developers. So, again, back to native packaging, assuming that you've selected an HTML5 deployment model. You're still repackaging these things and figuring out how to get them inside of a managed BYOD environment. So these kind of inputs, these problems that we were seeing in the marketplace kind of brought us to this point where we knew we had a great deployment platform, or we knew we had a great deployment technology in HTML5. It could do a lot of great things for us. We can build really high fidelity apps that run relatively well on a mobile environment. And you write it once for the most part, and it runs across all these platforms. So you get a huge developer productivity gain. You don't have to have Android developers and iOS developers and Windows developers and Tizen developers and Firefox OS developers and whatever else comes out next month. So, and the web has a lot of other interesting features that tend to break once you're inside of an app, like being able to communicate between apps and transfer data between apps and linking and things like that. But we also needed the ability to do the security things that the IT department wanted. So we needed, once the data leaves their data center and winds up on your device, how do they make sure it doesn't leave the company unexpectedly, either via the theft of the device or via some kind of network hackery, or just a malicious employee, perhaps. So that's how we came up with Sencha Space. So Sencha Space is, in a sentence, a secure managed environment for business applications that works on every mobile device. Effectively, simply, it's an enterprise-grade browser. So, just for a minute, let me talk about the experience you'll have as an employee using Sencha Space. So you started a new company, and they're using Space. So you go to the App Store. You don't go to the IT department. You download the Sencha Space app for your platform of choice. Right now, as of today, we support Google's Store, Apple's Store, and BlackBerry, and probably more in the future. You get some login credentials from your organization. You type them in to Sencha Space when you launch it. And once it starts up, you're greeted with a home page. And that's just a web page selected by your organization. It could be anything. It could be your internal portal. It could be an HTML5 app. It could be pretty much whatever you want. There's an app menu. So all the apps that you need as an employee show up here. Now, contrast that with the normal behavior for web deployment, which is email. Here's an email with all the apps that we use. Or there might be 20 emails with one link in it each. And then you have to figure out how to arrange your own bookmarks. Well, somebody has decided that these are the apps that you need to have access to, and they automatically update. So when the IT department moves one of your line of business apps, let's say your time tracking tool, your time off, vacation calendar, whatever, if they move it, the URL changes automatically, and you never have to update your bookmarks. So this is a always updated list of all of your web apps that you use on a daily basis. When you click on one, this is a Sencha Touch app we built as a contacts example. You can browse around. You get normal browser controls, so forward, back, reload. And we have a favoriting feature, so as you're navigating through the app, you can favorite a page, and then they show up in a sublist underneath the application. So we keep everything organized, and we make it easy for you as a user to get quickly to the things that you need to have access to. Now, that last example is a Sencha Touch application, but because this is a browser, you can run any web application, or any website for that matter. It doesn't have to be HTML5 compliant or whatever. As long as it runs inside of your mobile browser, you can run it inside of Sencha Space. We allow you as an end user to belong to multiple organizations. So depending on how large your company is, you might have to be part of multiple organizations to be part of one publicly traded entity. That's a real use case. Or you might be a consultant and you work for multiple companies. And so from inside of Sencha Space, we allow you to log into multiple organizations and switch between them. And unlike consumer browsers that have, if you're using Chrome, you have a limited capability to do this, but we keep everything isolated. So when you switch from one organization to the next, all your cookies, HTML, cache, local storage, databases, whatever else, is moved out of the way and is associated with that organization. So let's say you're logged into Salesforce in one organization and you have to use it in both. When you switch to the other organization, the cookies associated with Salesforce for that organization get copied in. So you can quickly switch back and forth without logging in and out of your web apps. Same for any web app. So that's kind of the end user experience for Sencha Space. It's basically a browser on Rails, so to speak, where you are given the places you need to go to. So what do you do as an administrator? How do you get those apps into that list? So we give you a login, and you get a nice dashboard for your organization. You can quickly see how many users you have, apps you have, what kind of basic activity. You can also see all the devices on your network that are using your apps, that are logging in. You can see where they are, who they were, and what kind of phone they're using. You can get a list of users, and then from the list of users, you can see, again, all the devices that user uses and how frequently they've used them and where they were when they used them. Now, another important feature of Sencha Space from an administrative standpoint is that there's a little X next to that to each one of those devices. So let's say some strange phone pops onto the network logging in from somewhere in China, and your employee happens to be in New York. You can hit the little button there, and through the network, we delete access for that device. We block access for that device. So this is a big difference between web and app deployments, native app deployments. From an administrative standpoint, you can immediately revoke access to any given device or an entire user at any point. Right now, we support the version that's up on the web right now. The developer preview is email invite only. It's a great solution to get started easily, or if you're a small company, or if you're managing a handful of users. You can organize, well, before I go on to the next slide, we're building out the capability to connect to identity providers. So I don't have a slide for this, but basically, if you've got a corporate LDAP, Active Directory system, or a cloud-based identity management system, we'll be able to connect into that, and your users will get managed for you automatically. So you don't have to invite them manually. We let you group your users together, and again, you can either do this manually, or in the LDAP identity scenario, you'll be able to map your directory structure to groups. You can put users into those groups, and just as importantly, you can add apps to those groups. So when I was talking about when you log in to Sencha Space and you see a list of apps, this is what gives you that list of apps. And so you can have different sets of apps for different sets of users. Your engineers probably don't need to see the Salesforce URL. At least I hope not. So what are these applications? What do you have to do to get an application into Space? Well, fortunately, it's just a URL. It could be any URL. Maybe you've got stuff up in the cloud, in the public cloud, private cloud, behind a VPN. As long as it's a URL, as long as it can be loaded in a browser, you can run it inside of Sencha Space. But what about internal apps? Now, a lot of apps, a majority of the apps your enterprise uses, I'm guessing, are probably behind a firewall. And how do you get, on a mobile device, access to those apps inside the firewall? Did I delete that slide? Oh, well, I get to just talk about it. Anyway, so is anyone familiar with the VPN concept, per app VPNs or clientless VPNs? It's a relatively new standard where it's basically you're using SSL and VPN-like authentication to tunnel directly into an asset inside of your data center. This is an alternative to the BYOD type solutions or the mobile app management solutions where they, when they root your phone, they get to put VPN clients and credentials onto your phone, where it's basically taking your phone, once you authenticate to the VPN, transporting your phone somewhere inside of the data center, inside of the DMZ, so that not only the app that you're running has access to the corporate app network, but every app on your phone has access to the corporate network, and it's fairly tricky to create a VPN configuration that only works for the resources that you want them to. Split tunneling, it's relatively complicated to set up. We're working with VPN providers to use their clientless VPNs, where effectively an internal URL gets mapped to an external URL, and you authenticate with a certificate or a set of username, password type credentials, and you're given point-to-point access between the public URL and the internal URL. So your phone, the network stack, is never actually exposed to your corporate resources. It's actually a more secure way to do it. We think this is a good solution, and we're working with, like I said, VPN companies to get this going. So inside of Sencha Space, you'll be able to fairly quickly add access to your external resources and your internal resources quickly and easily. There's no packaging process, no deployment process. Just put it up on a web server, just like we've always done, and we're good to go. So that's Sencha Space from an IT perspective. So we keep your work apps and your personal apps separate. We allow IT to manage access to those apps and to the devices. And your existing web apps just work. No additional magic required. So that's Sencha Space from the first two customers' perspective. But Sencha's always been a developer company. We're about developers, we're by developers, for developers, and we wouldn't, Sencha Space wouldn't be all that interesting without an SDK. So we want to give developers a new set of tools to build apps better and faster than they can with a regular browser. So that's the Sencha Space SDK. We wanted to keep it as simple as possible. Who likes really big, complicated APIs? Yeah, I knew you. Yeah, John, thanks. There's always one in every crowd. Hundreds of kilobytes added to your app to add stuff to space. Probably not a good idea. So by starting with the goal of keeping it simple, we also kept the API simple. And so to add Sencha Space to your app, it's only about a 7 kilobyte gzipped hit over the wire. But even 7 kilobytes, that's a little bit too much. So because we've got a client, we've got a native app, we can download that once and share it between the clients. And so if you're using our CDN hosted space URL, if we detect that we already have that cached, we don't need to download it again. So the effective overhead is going to be 0 for most apps. And because we're storing it on the client, we can update it automatically. So with the Space SDK, there's actually nothing to download. There's nothing as a developer even. There's nothing to install. There's nothing to unzip on your disk. You just include a URL and you get going. And that's, again, back to keeping things as simple and as easy as possible. And the biggest thing for us is because our frameworks tend to be fairly vertically integrated. If you use Sencha Space or Sencha Touch or EXT, you're pretty much using everything we got. We've got a low-level class system, we've got a loader, we've got UI components, data packages. We give you everything, right? We give you the whole cake. You can start your development inside of our frameworks, and you can end your development inside of our frameworks. But we know the reality is not every app has been built with our technology yet. And so what we wanted to get, we started out with a library that would not require any of the other bits of our frameworks. So you don't need to load ext core, you don't need to load anything else. And not only did that keep it really small, but it means that you can use Sencha Space APIs with any app, built with any technology that runs JavaScript. So if you're using jQuery, using Dojo, whatever you have, you can add it in with a few lines of code and get going. And this is how you do it. So you put a script tag. We all know how to do script tags, right? You put a script tag in your HTML page, and you're done. Anybody familiar with if anybody's done any work with native packagers, there's a little bit of a lag between the time the web view is created and the time that the JavaScript APIs are ready to be used. So we have our own custom onReady callback, just like you would in Cordova. So if you're trying to do space APIs on startup, wrap your code in that little bit, and you'll be ready to go. Because we want you to be able to build apps that run both inside and outside of space, we give you a little Boolean that says, if it's space, do this. If it's not, do something else. And this is another big one for us, is we've adopted the Promises API. And John sitting in the back will appreciate this. But basically, Promise is a representation of an eventual result of an asynchronous operation. So that's the Promises A+ spec. Is anybody familiar with Promises? Maybe if, I don't know, was your talk on Promises at all? On when? Okay. So is anybody familiar with Promises? Nobody? A few? Okay, cool. So I can go through this fast. So what is a promise? You can create one, you get an object back. You can either at some point fulfill the promise or reject the promise, and you can pass data back. What does that look like? So I got a little wait function. You create a promise. Let's say we wanted to use set timeout to actually do the waiting. When the timeout executes, I fulfill the promise. And the most important bit is I return the promise from the function so that the caller can actually use it. So what does that look like if I consume a promise? Something like that. I have a failure callback and a success callback. So should be good to go. Any questions? Sorry.
Is this promise going to be in EXT.js and such?
That's a good question. some of the frameworks teams will probably start to incorporate this throughout. We've got a lot of the release cycle for the frameworks is pretty well loaded up at this point for the remainder of the year. But I could imagine this starting to be incorporated across the board. The other thing is we don't really want to build our own promises library because there's lots of good ones out there. The maintainer of one is sitting in the back of the room, and right, John?
I'll stay with Brian.
Yeah. So there's lots of good ones, and you don't necessarily have to use ours. So as long as it complies with the spec, you should be good to go. But that was just like a little tutorial on promises, because all of the Space APIs return promises. Everything that we do is asynchronous, and partly because we're dealing with JavaScript bridging between native and the JavaScript land, which is an asynchronous operation, and all the security stuff I'm about to talk about is also, relatively speaking, slow. So there are 3 big APIs that are part of Sencha Space. And before I talk about those, we're also giving you a lot of the APIs you come to expect from a native packager. So if you look at Cordova and the default plugins that they provide around cameras and sensors, GPS, all that, orientation, accelerometer, we're giving you the native, similar APIs to what you'd find inside of a packaged app. And we haven't decided on exactly what we're going to add as well, what plugins we're going to add support for, but we have had a lot of interest in a fairly specific set of enterprise-oriented plugins that you can add to PhoneGap or Cordova. So we'll probably be adding those in as well. But we've got some of our own fairly unique ones. So Invoke is probably the most interesting. Invoke is the ability for applications to communicate with each other inside of the container. So one of the things that we've been running into, and if you've built complex applications that run inside of a browser, is you kind of have to put everything inside of the browser window, right? And the ability to communicate between windows is fairly limited. There's a few kind of primitive APIs to do that. And if you're talking about native apps, it gets really difficult to actually exchange meaningful data back and forth or have them communicate inside of the phone. Now you can always go back to the network and kind of go back up and down, but that seems like a 500 millisecond round trip just to exchange some data. Seems a little excessive. So because we have a managed container where all the apps that we run inside of that container we know about, we can actually give them privileged access to each other. So I've got a fairly simple example back to our contacts app. Let's say as part of the contacts app, I want to know, or I want to be able to chat with the IT department. And I want to know, but before I click on the chat link, I want to know if they're online. So normally, you've probably done this before. You might have like a chat library, you might have a chat server in your company, or you might use something up in the cloud. So you download an API and you figure out how the JavaScript works, and you write a bunch of code and a bunch of UI, and you're good to go. But that takes a lot of time. But what if you already had an app that knew how to chat? You probably have a dedicated chat app running inside of your organization. Well, wouldn't it be great if you could just talk to that chat app and say, is this person online or not? So that's what Invoke lets you do. So as an application, you can say, Space, is there anything that knows about chat? And Space will say, yeah, there's an app that knows about chat. And what it'll do in the background is it'll create a new web view and start firing up and loading that application. And that application can do whatever it needs to do. It talks to the cloud, whatever. It doesn't matter. But it starts up and says, hey, yeah, I'm available and I know how to chat. And once I get that promise back, I can say, okay, well, give me the presence of this particular user. And that might take a while. It might have to go back to the server. Might have to find out where they are. But eventually, it'll come back and say, hey, yeah, they're online. And once you get that result back, you can then update your UI with the results. Now, this is a fairly trivial example. But basically, you can add a lot of complex application. You get all the capabilities of that chat app for with a few lines of extra JavaScript. And assuming my network connection is still functional, let's see if this all works. So I've got a slightly different demo that shows Invoke in a different way. So this is Sencha Space running inside a simulator. I don't have my real phone hooked up to the projector, so but if you want to see it on a real phone later, just come grab me. But basically, I've got this Invoke demo. And just to really drive home the point, this is an HTML page with no libraries in it other than Sencha Space. So it's raw, pure JavaScript, get element by ID, wire up the buttons. There's nothing in here but space. So, and I've got this Photos app down here it's a Sencha Touch app that I actually downloaded it off of our marketplace where you can find kind of pre-built example apps. And so, assuming everything is wired up correctly, if I tap the Get Photos button, now I'm in the Photos app. So I was taken from one app to another app. So what I can do here is I can pick some photos, and when I click Choose, I'm taken back to the original app. And this is fairly basic, so all I do is I dump the list of images into a div down there at the bottom of the page. But you can see I've now exchanged data and allowed user interaction between two applications running inside of Space. And that's, we think, is pretty cool. Because think about it, if you had to build a Photos app, or let's say you had an app that needed some photos, you'd have to go build a whole UI. You'd have to do a whole lot of things that would take a lot of time. And so if you've got to already have a Photos app inside of your organization or a team that just does the Photos app, you're done. Not a whole lot new to do. And so that's kind of the quick demo. So what do you actually have to do as a developer to add that to your app? So going back to the chat example, all you have to do to Space is say, get me chat. And that returns a promise. And if there isn't a chat app, you get the failure callback. If there is a chat app, you get a connection to that chat app. And you can make at that point, you can make as many calls as you want to the chat app via the connection object. Like I demonstrated with the Photos app, you can call things in the foreground. So if you need to interact with that app, if you need the user to interact with that app, you can go in the foreground, which is where you actually switch, like I showed you a second ago. And I think I've got a highlight there. So you can set the foreground Boolean to true. Now that first parameter there is the data package you want to send. It's a JSON object or a serializable JavaScript object, depending on your terminology. But basically, you can pass data. So the Photos example is fairly similar. But in this case, I'm actually going to respond, or I'm going to do something with the result that I get back from the app. So let's say I want to pass in a bunch of data that says I want to get all the photos from the keynote in the last day, maybe, and then do something with the photo once I get it back. So the use photos function could look like this. Basically, you get a JavaScript object. Whatever it is that the app passed back to you is what you get, and you can do whatever you want with it. Same thing for the background. This is the presence example I had in my diagram. So the only difference there is you're now returning false. You get the promise back, and on success, you can do what you want with the output. It's just a JavaScript object. So that's how you, as a caller, that's how you make an invoke call to another application. But how do you receive a message you're being called by another application? So we've got the similar method, this onMessage function inside of the Invoke namespace with a callback. So every time you get a call from another application, this part of the API is still in a little bit of flux. Right now, we just give you the ID of the application that that's calling you. But We'll probably have a little bit better object there for you with details about the application. And then the data that they sent you. So like I showed you at the beginning, you have to create a promise, and you have to return that promise, and then you have to do something in the middle to either fulfill or reject that promise. So what is a handle message? In this case, I'm doing some asynchronous call to some function called getUser. After I get the user back, I can grab their connectivity status and fulfill the promise. And if the message wasn't properly formatted, I reject the promise. So again, back to the cool diagram. That's how you can exchange data with applications using Sencha Space. Is there any questions about that? Oh wait, before I ask for questions, the first one I usually get is, how's this managed? The IT administrator, when they set up the app, there's a section where they get to say, here are the applications that can call this application, and vice versa. So it's the administrator that gets to decide who talks to who inside of the container. So if you have an application that is trusted, you give it access. If it's not trusted, you don't give it access. So are there any questions about that before I move on? On. Sorry, I had the mic off while I was coughing. So we think over time this is a new way to build applications. You know, typically when you build an application inside of the enterprise today, let me push the button, too many buttons. Try that again. All right. So typically when you build an application inside of the enterprise, you have to cram a whole lot of functionality into one app, especially if you're packaging it up and putting it on the App Store. You might be you might be one app for your whole company, or you might be 3 apps for your whole company that put a whole bunch of functions all into one box. And they all have to talk to each other, and you have to figure out some way to make that all work. You might have multiple teams. Those teams might be distributed across the globe, all working on their own schedules, their own timelines. It gets really complicated to build apps that way, right? I know I've worked on teams like that before. But what we think you can do, or what we hope we'll be able to do inside of Space, is break up those applications into smaller pieces. They can all be deployed on their own pace, their own release cycle, and all they need to do is maintain a simple API between them. And that way they can then communicate inside of the container, and really this could be a much more powerful way to build applications, because you can build applications that become more like services. They do one thing and do it well, and each team can release whenever they want to, and they don't need to coordinate. So that is Invoke. So before I move on to the next big feature of Space, any questions about that? All right, cool. So I made a big deal at the beginning of the presentation about security. And one of the main features of Sencha Space is security. And what do we mean by that? One of the biggest problems with, like I said at the beginning, is that once your data goes onto the disk, it's all in the clear. So your cookies, local storage, web SQL, IndexedDB, they're all there for the taking. if an attacker can get into your app, of which there are hundreds of attack vectors, as we found out through our security consultants that we've hired. It's really easy to basically crack open your device, especially on Android. Sorry, Android, but the amount of attack vectors on Android are significantly higher than on iOS, just to be frank. So what we wanted to give you as a developer is a secure data API. And first, I want to review what we get out of HTML5, what we all get to play with. So we've all had cookies forever, but they're a bit too small. You probably don't want to put too much data in your cookies, because then every HTTP request you're making, you're clogging up your headers with cookie data that may or may not need to be exchanged. We've got local storage. That's what we pretty much all use, right? But it's a little small. You don't get a whole lot of local storage space, particularly on mobile devices. And it's synchronous. So the API, when you say put an item, it's actually writing to disk and blocks until you're done. And that can be slow. And then there's Web SQL, which gave us tables and queries, and you could store a little bit more data, but we got rid of that because we don't want SQL, right? And then there's IndexedDB, and that's the new awesomeness, but it's not everywhere yet. So what are we going to do? And then the biggest problem is none of those APIs give you any control over what happens to the data once it hits the disk. So there's two things that we do. First, I talked about this earlier, about the multi-tenancy capability of Sencha Space, where for each organization you're in, we put all of your HTML5 assets into a box. And when you switch organizations, we give you a new box to fill up with all of your bits. And this is done automatically as part of the container. The other thing that we do is we encrypt the box. So we can't encrypt it all the time, but when you switch organizations, all the organizations you're not using are encrypted. The data that was originally there is securely erased. Whenever your app goes into the background, we encrypt the box. Whenever you bring it up for the foreground, we decrypt the box. So most of the time, your data with the HTML5 APIs is stored securely for free inside of Sencha Space. But there are still some, basically at runtime, while your web views are accessing that data, it has to be decrypted, because there aren't any ways for us to get in between the web view in Safari or on iOS and the file system. It has a direct connection. Same thing for Android. So for now, if an attacker were to get your phone while it was running and kept the app alive, they could get access to the data. And so we've narrowed the attack vector significantly, but there's still an attack vector. So for the ultra secure, highest level, before I get into all that ultra security awesomeness, cookies are the same way, right? You open up the file system on your iOS device and you look at the cookie file inside of your package app, and there's all these nice little cookies you can play with. But what we can do with the cookies is automatically encrypt those as well. So as they're being written, they're getting encrypted. So you get that for free without building anything to your app. But we wanted to go further than that. We wanted to extend beyond what HTML5 gives you for data storage, and we wanted to make that data storage secure. So every app inside of your organization gets its own encrypted database. And the keys for those databases are different for every single app. So if one app is compromised, all the apps aren't compromised. If one organization is compromised, the other organizations are safe. So we give you a much higher level of security. And what we're calling this is basically secure local storage, for lack of a better name. What does that look like? So all the data is encrypted before it hits the disk. All the APIs are asynchronous because, as you know, encryption libraries take a little bit of time compared to just writing bits straight to disk. We give you an extra feature of multiple collections per application, which is a little bit more convenient than local storage where you have to do the namespacing all by yourself. And the big one is we give you much, much higher storage limits. So like I said, local storage is maybe 3 to 5 megabytes per domain on your for your browser, or even inside of a packaged app. And if you added cryptography overhead, you're looking about it's a 3 times increase in storage space to encrypt all your data. So you're looking at like a megabyte, maybe a megabyte and a half. And so if we encrypted all your local storage stuff, you wouldn't have a whole lot of space. And that's not good. So because we're using our own database technology, or it's not ours, but we're using a non-HTML5 database technology, you can store tens or hundreds of megabytes of encrypted data inside of your app. And we're effectively limited only by the size of your app, the size that your app is allowed to be inside of the App Store. So all the app stores have default limits for app sizes. So whatever that limit is, that's how much data you can store. So that's a huge, huge change for app developers, because now you can store lots more data. And you can be secure and be confident that the data is not going to fall into the wrong hands once it is on the disk. So you can start to build different kinds of applications. Because what we were finding with our customers is they were disabling cookies. They were disabling local storage. They were disabling everything because they couldn't trust the browser to store the data. So when they were building apps, they had to be always online. They had to download all the data every single time they loaded up. They were, not putting anything anywhere. And so this gives them an avenue for building applications that work more efficiently, that use less network resources, and that maybe someday work offline. So we wanted to keep the API as simple as possible, and because local storage has a nice simple API, so we wanted to try to copy that as much as possible. Basically, you say get a collection of things. You can set that collection, by keys. So you say key, and then you can put in an object. You can get that key back out with a promise for when it comes back to you. You can delete just the collection and not all the other data that you're storing in local storage. So we can do that quickly and efficiently. You don't have to loop through all the keys and find the ones you want to delete. More functions. We can quickly check to see if you have a key or not without decrypting, then deserializing the data. We've got an iterator, so you can loop over all the data in an asynchronous fashion. And we give you a quick count function, so you don't have to grab all the data to count it. So that is, I believe, clear, yes. So if you want to blow away everything, you can have at it. So we do have some nice Sencha Touch integration. If you are a Sencha Touch customer, we give you a local storage proxy on our data store. Or actually, sorry, that's the original one. So if you're normally using, let's say, the local storage data proxy, you can change that just slightly. You can use our SecureSql Proxy, give it a table name, and change the type to SecureSql. And sorry, go ahead.
When you say it's bigger, how big is it?
Which big? What?
Secure local storage, you say it's much more space.
Yeah, so it's basically, we're effectively limited by the app size. So your app store might say your app can only be 50 megabytes or 100 megabytes or 500 megabytes, whatever. We've tested it up in, theoretically into the 2 terabyte range. Or no, 2 gigabytes, sorry. Wrong. I'm off by order of magnitude. 2 gig, yeah. So we're future-proof. Well, basically it's a function of the encryption speed. So as the CPUs get faster, we're running into file descriptor limits basically, and there may be better technologies. Right now we're using a SQLite database. There's which we're effectively limited to SQLite database storage sizes. So if we were to switch to something like the new awesomeness, which is level DV, we might be able to go larger, but we're effectively limited by the phones at this point anyway. So I mean, Apple didn't even release a 128 gig iPhone, which is kind of obnoxious. But anyway, that's my aside. So yeah, I mean, we're basically going from handfuls of megabytes in local storage or WebSQL or IndexedDB to tens of megabytes, and it just happens to also be encrypted. So I don't know, is anybody using Sencha Touch in the room? I don't have any, oh, okay, cool. So yeah, if you're using Sencha Touch, that's what the Contacts app actually pulls the data down from the server and sticks it into a SecureSql Proxy, and so all your contacts are stored in an encrypted fashion. Yeah, that's so. This is my if you're using if you're using Touch, you can just grab the store. You can add a record, and when you call sync, it's written in an encrypted fashion, so you can keep the things you really don't want anyone to know, like my favorite artist and my social security number there. So glad that isn't out there. Maybe I probably should have updated that for Miley. A little more, Anyway. Yeah, so that's the example app is running with the, you can download off GitHub is using the SQL proxy. So that's secure storage. Let's see, how am I doing for time? Oh, I got plenty of time. Secure files. So secure files, the API is basically the same concept. So if you have unstructured data you want to write to the file system, you can do it in an encrypted fashion. But what we wanted to do, we give you basically the web file standard. We wrap that API, and so if you're writing with that really low level API, you can get encryption for free, so to speak. But I wanted to give you we wanted to give you a much easier way to access your files than managing directories and doing all the stuff you have to do with the files. If you've looked at the API, it's not the best. So basically, it's simple. We keep it really simple. You can save a file either as a string, an HTML5 file object, or just a JavaScript object, and we'll do all the marshalling and serialization for you. You can get your file back out as a string. You can get it as a data URI, and you can get it back out as an object. So yeah, a little bit simpler than doing things the W3C way. You can delete files, you can loop over files, you can count files. It's all basically the same API as the data storage API, just with files and not with data. So that's our simple wrapper on top of the file storage API. So one thing I forgot to mention, I don't have a slide for it, but we also give you a low-level SQL wrapper. So because we are using SQLite, if you want to write raw SQL and create tables and have them all be encrypted, we've got the raw, the low-level SQL API as well that you can use if you want. So if you want the power of writing complex queries that are allowed by SQLite, you should be good to go. Is there any questions about storing encrypted bits on the disk? All right, cool. So that is the end of my slides, but I have code if anybody's interested in looking at it. So one of the examples that I didn't show you, and this is where I really meant it when I said you can use any application from anywhere and add Sencha Space APIs to it, and it'll just start working. So what I did to prove that was I downloaded the to-do MVC example, the default jQuery one, the most basic one without any extra bells and whistles. Is everybody in here familiar with the to-do MVC project? Okay, so for those not familiar, it's basically a repository on GitHub of every single JavaScript MVC library out there implementing to-dos. So it's kind of the reference implementation for you as a developer to decide which way do I want to do MVC. And there's, I don't know, 50, 100 projects out there. Everything from the big guys, Angular, Ember, Bootstrap, jQuery, jQuery Mobile, and Cujo's got one. There's thousands of them. And we've got ours in there. It's just like it's the bazaar, man. There's everything you could possibly imagine. So some pop on there that I've never even heard of. But anyway, this is what it looks like. You know, and it's not really a mobile optimized UI, so it's a little hard to use. But basically, you know, you can type in to-dos, and you know, you can check them off your list. So anyway, so it's a really simple app. And normally, let's see here if I can get this to work. Because I'm running the simulator, I can pull up my debugger. Let's see, which window is that? There we are. So this is the version that I've converted. And as you can see, now normally there'd be, if you go to the regular one, there's local storage there. But, and normally this thing's writing local storage, but as you can see, there's nothing in the browser. Let's see here, body, section. Should be able to see the stuff being added as I don't know what the DOM looks like, actually. There we are. Okay. So as you can see this is live, right? So you can, there should be, see the LIs popping in there as I type stuff. So I've got a nice live view in there, but every time I add one of those, the regular version would write this to local storage. So in my demo, so here's the list. So this goes kind of fast. So I have a little button that says new to do, and I didn't even bother putting an input element. I just have a hard-coded piece of text. So if I click this once, I think you probably saw the LI update there. But basically, it went in the background and just created a new to do for me automatically. And in theory, is it the top one? No, it's the bottom one. Yeah, so from invoke test 1. And if I switch back over to the jQuery app, now there's my invoke test now at the bottom. So I'm making a background invoke call to a jQuery app that then gets stored in secure local storage. Kind of cool. At least I think it's kind of cool. I don't know about you guys. No. This is so if you're running on the newer version of, actually I think it's been around for a year or so now. But this is Safari's debugger. So if you're running the iPhone simulator, if you've got Xcode installed and all that stuff, whether you're in Safari or in an app that uses web views, you can go into Safari and get this iPhone simulator, or if you're a full Apple developer and you plug in a real device, you can attach the debugger and it'll show up here in the list. But basically, you get all your web views. And as you can see, we've got a whole bunch of web views all running simultaneously inside of the container. Basically, yeah. So that's what allows us to switch this stuff so quickly, is the view's just there already. Excuse me 1 second. My apologies for the coughing. So let's look at the code. Yeah, so this is my README. This is all up on GitHub. Sencha Space examples. So if you want to take a look at at our GitHub repo, you can see all the code for all these examples, and some of the ones I won't have time to talk about, or probably won't have time to talk about. But basically, this is a fairly simple jQuery app. It's got some, let's see, it's all inside of a jQuery wrapper callback. It's got some utility functions and a init. So the original code looked like that. It was basically setting up the store. And then it ran all this code down here. But because, like I've said, our data API is asynchronous, and you can't just start writing into it until it's ready, I had to change the code a little bit to make it asynchronous. So now the store utility store method returns a promise, and then once the promise returns, that means I've got the data. So if I go back to and again, I wasn't trying to rewrite the app to make it be a perfectly awesome app. I just made the minimum number of changes required to get the job done. So if I was writing this app myself, I might do it a little differently, but this is the way they did it. So if I go back up to this utils class and the store function, is that big enough in the back for everybody back there? Okay. So basically, it's so this is the original code, just for reference. Oops. I did not mean to minimize that. How do I unminimize that? Screw it. Yeah, I did collapse it, and I don't remember the key combination to uncollapse it, so I'm going to hope that it doesn't remember. Right, okay. I meant to uncomment. So this is the original code. Basically, the store function, it serialized all your to-dos into a single item in local storage. So you give it a namespace and then the data, and it would stringify the data and stuff it into local storage if you passed in the data. If you didn't pass in the data, it's assumed you want the data, and it would return either the parsed JavaScript data or an empty array. So fairly simple. But the code I get to write is actually a little bit simpler than that. So all I just have to do is say get namespace, and if I pass in a data parameter, then I just set the data parameter. I don't need to serialize it because the library, the local storage API, our local storage API takes care of that for you. And if I don't pass in data, then I just return the promise to get the items back. And so the code actually ended up being, it's about the same number of lines, but it's actually a little bit simpler and complex. It's less complex. So that's basically all the storage stuff. There was one other bit of code I changed. No, that was on the to-do. So basically, every time you add a to-do item, they call store.store with the whole thing in it, and it gets serialized back in. So it's not exactly super efficient, but I didn't want to take the time to rewrite all the UI code to actually, put everything into multiple items. But you could have done that. I could have done that. But basically, I just, making the minimum number of changes to make the thing work. Sorry? Yes, I can do that. Yeah, so as a developer, if I'm playing around, I could just write the ext local storage, secure local storage.clear and blow everything away. If I'm just a developer, but if I was an administrator, if I didn't want the user to have access to that particular app, I could just delete the app from that user, and poof goes the data. If I want to block their device, I block the device. The entire organization, the entire container, all the secure data first thing we do is we delete the keys. So you can't decrypt the data, and then we delete the data. So deleting the keys is much faster than deleting the data. And the data is pretty much useless without the keys. So as an administrator, like operationally, I wouldn't need to go in here programmatically and do anything. I can do it at an administrative level.
In that console,
in the console, yes. So that's the local storage bit, and the invoke bit is a little bit longer, but mainly just because I wanted to make it readable. So invoke, I created this little invoke object with an init method on it so that I could call it later on when the app is ready, and I say on message. So whenever anybody calls me, I get a message. So I create the promise, and I return the promise, and then there's this handle message function where I basically do the app-specific logic to actually add the item. So I check to make sure there's a to-do on the message. If not, I reject it. And this is how the original app, I just copied and pasted this. It basically took the to-do array and pushed a new item on it. They generate a UUID for some reason, and the title, and that's it. And then you call render, which does all the DOM re-rendering to reflow the array back into the DOM. And I fulfill the promise, and that's basically it. So I copied and pasted some code out of somewhere else in the app. Maybe if it was a better, more factored app where there was actually just a method that I could call, maybe it would be a little easier to write, but that's what I had to work with. So that's all the code I added. We're talking maybe 50 lines of code with all the spaces and the comments and things. So that's all I really had to do to make a jQuery app that was storing stuff in local storage in an insecure fashion, store it securely, and then allow it to work with invoke calls. So that was kind of cool. But I've got this chat app over here, and it's a fake chat app. It's not real. I'm not actually sending any messages. But one of the other things is that the chat app is also wired up to make to-do calls. And let's see. So I've got that guy down there, and so test to-do from chat. So if I long press, and this is a touch app, right? So if I long press on the to-do, I get a little touch dialog that says, hey, do you want to create a to-do message? And this is a little fast because normally the app was, this is calling it in the foreground, and the jQuery app just immediately returns because it doesn't have a dialog for adding stuff. Our more functional to-do app has a dialog. But anyway, so when I hit the yes button, it'll flip over to the to-do app and then save it and then flip back. Oh, wait, I hit no, yeah, okay, cool. So let's see what happens. So if we go back over to the to-do app, now there's a to-do item at the bottom. So now I've got two apps. You know, the chat app didn't even know about the jQuery app. We could switch to-do apps if we wanted to. We could have, I guess, multiple to-do apps because it's not in the developer preview, but the 1.0 version we're working on gives you a dialog. So if there's multiple apps that expose chat or to-do or photos, you'll get a little dialog that says, here's all the apps, which one do you want to use? And so I hope you're getting the idea that you can actually start to build some cool applications, some services. And really, if you take this to the extreme, you could build an app without a user interface and have an app be a pure service. Because if you make all the calls in the background, you don't really need to have a UI. So apps can start acting like API providers or proxies for APIs. So that's some of the stuff we're working on. Let me show you the Photos app. Are there any questions about the jQuery app? Feel free to interrupt me.
I have a couple of general questions.
Yeah.
Two, so if I just want to download Spaces, and I don't have, just to start playing around with it, is that pretty easy to do? Or?
Yes. I have a slide for that.
Are your slides on the passed out?
No, I got an email yesterday saying we need you to give us our slides. So I will get them put up on that or wherever it needs to go. So I think that's a website or something that they can update. So
I have another quick one.
yeah.
The other one is, so at the very beginning you showed that example where you can, from the admin perspective, see all the users, and you can say, hey, there's somebody from China.
Mm-hmm.
This guy's really in New York City. But that's fine if you know all your users and you have a small set. What if you had like 10,000 users? Is it possible to automatically detect that?
Yeah, so that's something we're working on.
API or
Yeah,
how do they?
that's definitely something we're working on for the 1.0 release is, and I don't really talk about it in the slides because we're still building it, but basically there's going to be a policy engine inside of Space that the administrator will have a bunch of knobs they can fiddle that say, create geofences, create password requirements, pen strengths, time of day, networks, all these rules basically about when the app can and can't be used by this user. And you'll be able to assign those policies to different users. And then on the phone, both on the server and on the phone, we'll be able to enforce that policy. So if the phone starts up, we may be able to say, hey, you have to have GPS turned on to use Space for this organization. And as the administrator, you could say that. And they have to be inside of this geographic region. And if you can't, if GPS is turned off, you can't use the app. So we're working on building this policy engine and trying to make it as secure as possible. So again, it can't be compromised, but that's the way we're going to handle that problem.
Is there going to be a way to do APIs if I want to come up with my own stuff to look through all the users that are currently up?
Yes,
The server side API.
that's a good question. It's not something we have necessarily planned, but it's definitely something. I mean, we have an API for that. We used it to build our admin console. The question is, do we make that API public or not?
I'm just curious.
Yeah. So, but that's definitely something that would be probably fairly useful to have, and we will most likely do something around that along those lines.
So I gather that right now the way it's set up is that all the back-end stuff that runs the space, the admin console, all that is something you guys are hosting somewhere.
Right.
The obvious question I'm sure you've heard before is there any plan to let people actually deploy this inside?
Yes. Yes, there is. Yeah. So the question is, am I going to be able to host this myself? And the answer is yes. We haven't decided when. We're working with a set of early adopter customers right now. We launched this thing originally back at our conference in July, so it's been out for about 2 months now. At least in a developer kind of preview mode, we've got an overwhelming actually amount of interest from our customer base, and a lot of them have come to us with that question: when can I put this inside of my own data center?
I trust you, but
Yeah. Well, that's the
no way I'm letting you have access to my LDAP servers.
Yeah, exactly. No, exactly. Well, and so there's when we're not planning on doing direct LDAP integration ourselves, we're working with some of the big identity providers that do this already. So there's several large providers in this space. I can't name names because we don't have any formal agreements yet. But basically, there's guys that have already done the last mile integration. They're already sitting inside of your data center. If you have a single sign-on solution, we're working with those guys to make sure that you won't have to manage users. We'll defer the identity management to somebody else. Because we're a software company. We're not in the game. We're not an IT professional services shop. We don't do those kind of integrations. So the answer to your question, or both your questions, I guess, is yes.
Yeah, right. That's all
Yeah. So I think what time am I supposed to be? I think I'm supposed to be done at 10. Any other questions? I can talk about the space, the touch, the file browser app. It's fairly similar. What?
One question.
Yeah.
How is your offline support? You offer APIs for that, but of course your security kind of requires you to touch base to know whether to deactivate someone.
Yeah.
We often have a scenario where we have Sencha touch apps and we've made them work offline, so you go into a meeting where there's no connectivity.
Yep.
It's important you show the app and then you can launch it and so forth.
Yeah. So what's our story around offline is the question. So that's kind of a multi-layered question. There's multiple layers to that. So we're running. We're a browser, so we support app cache for better or worse. So you can, if you set up your manifest correctly and you can version your apps, and we can support offline that way. So if you can get your apps cached onto the device, there's that. Again, going back to the authentication policy, again, that's a dial that can be tuned. So you can say, this user always, all my users have to be always online, and I have to authenticate them every single time. That's like one extreme. Or you can say, dial that back and say they can be offline for X number of hours, days, weeks before they have to come back online. Because you don't want a device that can be offline forever. And you can say, if they're offline for too long, we delete their data automatically. So the next time the app starts up, their data's gone. And so we do have the ability to do PIN or passphrase based offline authentication. It's not something I can demo yet. It's still in development as part of our policy engine. But basically, you'll be able to enter in a PIN, and the PIN is what controls your security key, your encryption keys, and that will allow you to authenticate while you're offline. So you don't have to go back to the server to get authentication credentials. As long as your session is still valid based on the rules of your organization, you will be able to access whatever apps you have that are already offline. So that's kind of our initial offline story. As everybody, or if anybody's done any work with app cache, they know it's not the easiest thing to play with. It's actually very difficult to do correctly. And we're looking at ways to, because now that we have a browser that we can control, looking at ways to build APIs that give you much more control over offline asset caching through JavaScript. So there's a proposal for a standard called navigation controllers. It's kind of working its way through some people at Google, and it basically gives you a low-level JavaScript API that allows you to say what assets do you want to cache and how often do you want to refresh them. And it gives you programmatic control over your offline capabilities. So that's another thing we're looking at. May give you a much easier way to build offline apps. The other option is we can just tell you to zip up your app and upload it to the admin console, and then we can push the app to you directly. There's no need to download it at all, or at least download the pieces individually. And so, there's a lot of things we're looking at, but we haven't really, committed to anything other than what HTML5 gives you for offline asset caching. Does that answer your question?
Yes, you can.
Yeah.
We generally wrap it in Cordova, and then we're pretty much safe.
Right, exactly. So you wrap it in, if you're looking in packager land, you're effectively zipping up your app and putting it on the App Store, right? So it would make sense for Space to allow you to zip up your app and automatically deploy it. And because we know about all your users, we can know which versions they have, and we can automatically push new versions of the app, or maybe even push deltas. And it's definitely something we're looking at. All right. Any other questions? All right, cool, thanks. Well, I'll just go ahead and wrap it up now. If you have any questions, I'll be here.